Hi! In this lecture, we will start with the easiest collection type, V-array, which is variable-sized array. If you are familiar with another programming language, you should know about the arrays. V-arrays are the exact match of the arrays in other programming languages. We have a list of variables, this list is bounded, and the size is specified at the declaration, and we cannot change this size after the declaration. Actually, we have two methods to declare it. We can change with one way, but you will understand when I show that with examples. So I'm passing over this for now. The maximum upper limit of V-arrays are up to 2 GB, and the elements of V-arrays are stored in an order in the disk. Besides, we can create a V-array type in the database using SQL. We use V-arrays when we want that our upper limit is certain, but this restricts us since we cannot update this limit. So we need to be sure that our program will not add any value exceeding this limit. Otherwise, we will get an error. Some important information about V-arrays. V-arrays are bounded, as we said. Its index starts from 1 like the other collection types, but unlike the other programming languages. V-arrays are one-dimensional arrays. You can go further, but you cannot go back in a loop. This is a cons for the V-arrays. V-arrays are null by default, so you need to initialize them before using. We can either initialize them at the declaration or we can add values by extending. We will make examples for both of them. Okay, now let's make some examples then. We will start with a simple example and continue with harder. First, we need to declare our type. As you remember from our previous lessons, we declare a type for the records and said that there are some other types that we can create with type command. Now we will create a V-array type. So let's continue. Type e_list is V-array. It's 5 of varchar 2 and let's say 50. Now, what we did in here? We said that we will have a type as a V-array and its upper limit will be 5 and its type will be varchar 250. We created our type and now we need to create a V-array with this type. Employees e_list. Now, employees is our V-array with the e_list type. So let's write begin. Now we need to initialize our V-array to be able to use it. Otherwise we will get an error. We need to use the initialization function to do that. So what is the initialization method? It's the name of our type. Let's see how to do that. Employees is equal to e_list parentheses, let's say Alex, Bruce, John, let's say Bob and Richard. As we can see, we initialized our employees V-array with using our V-array type name, which is e_list in here. We did that with writing e_list and the values inside parentheses with separating them by a comma sign. Pretty simple. As we did our initialization, now we can use our V-array. Let's use it in a loop and print all of them. For I in 1.5 loop. dbms output.putLine employees and inside parentheses I. Great. We reach to the values of our V-array with using its index number. We know that the index number starts from 1 and increases by 1 automatically. Every new value will have one greater index value. As we can understand from the list, Alex has the index 1, Bruce has 2, John has 3, and goes on like that. To reach that, we simply write our V-array variable name and the index number inside parentheses. So end loop and our end. Great. Now we completed our code. Let's run and see if we did correct. Let's correct here, clear up and run again. Perfect. As we can see, our employees are printed based on their indexes. Now let's check some important things. First, we said that our index must be initialized. So let's comment out the initialization and run the code again. Clear up and run. As we can see, we had an error. It says that referenced to uninitialized collection. So the database server has thrown an exception. Great. Now let's uncomment that code and check something else. As we know, we said that we cannot add values greater than the upper limit. So let's decrease our upper limit to 4 and try to run again. Let's write 4 and clear up and run again. As we can see, we had a different error now. Subscript outside of limit. Because we said that our V-array can have at most 4 rows, but we tried to add 5 values in it. So it's an error. Now let's make our upper limit to 5 again. Let's check something different. We specify that our V-array will have at most 5 values. It cannot exceed 5. But does it have to be 5 rows? Can it have less? In our example, we are trying to reach all of 5 elements. If we have 4, will we have an error? Let's check that. For example, let's delete Richard and run it again. As we can see, we had an error because we tried to reach to an element that does not exist. The 5th employee is not there, so we had an error. But there is something important in here. In the previous examples, we had some errors and none of our employees are printed. But now we could print all of our employees but had an error anyway. As I had explained in our first lessons of our course, we know that DBMS output does not directly print all the values. It stores and prints them all in one step after the code finishes running. Until our 5th employee, there was no problem. So they are stored in the DBMS output buffer. But when we tried to reach the 5th one, it had an error. So the DBMS output package printed the error first, because this is its method. It prints the error first and then prints what was stored to be printed. Then it printed our employees until the 5th one. But you need to be careful about that. You might have some problems in your actual job if you get this error. How? Let's say that you are making some inserts or updates in this for loop, and you are committing your job in each iteration. That is a terrible mistake because you inserted or updated 4 of your employees, but you could not do that for the 5th one. Generally, it's hard to find which of them are operated or not in a real work. So if you don't have an important reason, I recommend you not to commit anything before you are done with the V-array. Now, what if we could get the count of the employees that we inserted? We know that our V-array can have 5 rows, but you will not fill them up all the time. So we should learn how many of them are filled somehow. With this way, we will handle this error. Can we do that? Yes. PL/SQL collections have some functions that will give us some really useful information about our collections. I will not explain them all now, but I will explain them all on examples in this lecture and in the next lectures. They work for all of our collections, so we can use them in V-arrays too. One of these functions is count. With count function, we can easily get how many values our collections have. For this example, it will simply return 4, and we will easily be able to run for 4 times. So let's see that. How we use that? It's easy. We simply write our V-array name dot count with parentheses. I'm clearing up 5 and write employees dot count. Let's run and see if it works. As we can see, it worked without any error because it returned 4 and our for loop iterated for only 4 times, so we did not try to reach the 5th element. Pretty good and useful. But we can do that with some other methods. The first one is using first and last methods. Let's make our changes and talk after that. Let me copy that and delete one employees dot first, and let's delete count and write last. Let's clear up and run again. As we can see, we can get the first index value with using first function and last value with the last function. Is it useful? Not much. These functions are useful in associative arrays collection type, but for the V-arrays, the previous one is better because we know that its first index will always be exactly 1 and the last one will be the same number of the count. But anyway, you should know that we can use these functions with V-arrays too. There is one more way to avoid that error. It's by using the exist function. Exist function returns a Boolean true value if we have any value at the specified index. Even if we can check the fifth employee with using this function, it will not return any error because it does not try to get some value from that index. It returns true if there is a value at that index. Otherwise, it returns false. So let's make another change and see if we can do that with the exist command too. Now, let's first change our for loop to 1.5 again. Now we need to write an if statement. We will say that if this specific value exists, print it, otherwise don't. So I'm writing if employees that exists the index of I, then dbms output, put line, and end if. Great. Now let's check it. Let's clear up and run again. As we can see, perfect. There is one more function to show you for now. It's the limit function. Limit function returns the maximum size of a collection. For the V-arrays, it returns the maximum size of our array, not the count of the values in it. The maximum size that we specified while creation. It's useful when you deal with a V-array that is created by another programmer. So let's see that too. Let's clear up some codes and print the limit of our V-array. Employees dot limit. Let's run that. As we can see, it printed 5. We have 4 elements for now, but the maximum size of our V-array is 5, so it returned 5. Now, before passing to the next usage, let me show you something more. Can we create and initialize a V-array at the same time? Other programming languages let us to do that. Can we do that in PL/SQL too? Let's check it. Let's command the initialization in the begin end block and write that inside of our declare area. And let me copy that and paste in here. Let's run that. As we can see, we had an error. In PL/SQL, we cannot create and initialize a V-array at the same time with this way. We need to do that with how we saw in the previous examples, or we need to use the initialization function anyway, which is, let's write employees elist is equal to alist. Let's run it again. I think we executed without the semicolon, so let's run it again. Great. Now, these functions were to use the initialized collection. We initialized our collection at the first step, but this is not useful all the times because we did our initialization as hard-coded. What if we need to get these values from a table? We cannot write that inside of our code directly. We need to add them one by one. For these kind of issues, we have another option to add values into our V-arrays. Let's delete the previous code and create another example and explain the subject on that. Now, we need to create a type as usual. let's write type e underscore list is varray, let's say 15, and it's of varchar2, let's say 50. Now we need to declare a varray variable with that type, but with one difference. Employees again, e underscore list, it's equal to e underscore list. As we can see, we created our varray and initialized with an empty constructor, because we need to initialize varrays in all cases. Now we need to create an index variable to use later. idx number, it's equal to 1 for now. Now, we will get the employees from our table. So we need to loop starting from an employee ID to be able to get the employees. For I in 100 dot dot 110 loop and end loop. Now, here is the thing. We declared our varray, but there is no space allocated for that. So we need to extend our varray to have a room for a new value. So we use collections extend method to issue this. We simply write our varray name dot extend. So I write employees dot extend. Great. Now we will get the employee with the ID of our I value. That starts from 100 and goes up to 110. So we need to have 11 employees when we do that. We could do that easier with a cursor, but we haven't seen cursors yet, so we will write a standard select into clause. Let's continue then. Select first name into employees, the ID of idx from employees, where employee ID is equal to I. With this select into class, we will get the employees and assign the values into the employees array with the index of idx. Now, we need to increase the index value. Otherwise, we will be assigned all values into the first index again and again. The rest will be empty if we don't increase. So let's increase it then. idx is equal to idx plus 1. Alright, we have filled our collection. Now we can use it. So let's print the names one by one to see if we did correct. For x in 1 dot dot employees dot count loop and our end loop. dbms output dot put line the employees, the index of x. Great. Now let's run it and see if we could do that correctly. Perfect. With this code, we could see that we can add our variables into our varrays after the declaration. We can get our variables from a table, or we can get them from another collection, etc. Now, at the beginning of the lecture, I said that there are two ways to create a type. The first one is creating it inside of the declare section. We learned how to do that in our examples. This is stored in the memory and will be deleted after your program finishes. The second one is creating that type in the database. This time, the type stays in the database even when your program finishes. This is stored in database and you can use it with only referring it. This usage of type is called as schema level type. Now let's make an example for that usage and see how we use that. First, we will create our type. Let's simply cut our type declaration and write a create keyword before it. Create and paste it. Now let's run it. As we can see, type elist compiled. Now we have that type in our database. We can see that type under our HR schema. Let's check it. HR types. As we can see, this is our list. When we double click on it, we will see the create code. We can see the declaration of any types as a code by double-clicking like that. Now, we don't need to do any changes in our code. We can easily run because this time it gets that type from the database. The advantages of creating a type in the database are using in multiple programs and updating them when necessary. With this way, we can update our type after the creation if we need. Let me show you how to update a type. But first, let's run it if it works correctly. As we can see, no problem. Yes, I will show you how to update a type. We simply use the same code, but with create or replace command. We can create a type with this code too, or we can update like that. Let's see then. Create or replace, and let's change it. Varray 20 and varchar to 100. Let's run it. We could update our list now. It's stored in the database, so in the next one of our programs, they will see that type with the new changes. Let's refresh here and double click. It's our new values. Great. If it is stored in the database, we could drop it too. We can drop a type with using drop command easily. Let me write drop e_list. But before that, I write drop the type, it is type, drop type e_list. Let's run it. Our type has gone from the database. Pretty good. So, what have we learned from this lecture? We could create a Varray and added values both as hard-coded and from a table. We created many examples with true and false usages. This lecture is not only for explaining the Varrays, but we also learned how to use a type deeply with this lecture. Actually, type is a deeper subject and we will mention that in the further lessons. For example, we could alter the type instead of create or replace command, but this is not the subject of that lecture. So I showed you the easier and more memorable one. Besides, we learned most of the collection functions. We learned the general usage of collections and how to use Varrays specifically. So now you will be able to understand other collection types easily. Great, I think we learned all the things that we need about Varrays. So this is the end of the lecture. See you in the next lessons.